Every textbook says the edge of our solar system is a graveyard of dead, silent rocks. They are all wrong. Billions of miles away, in the pitch blackness of deep space, there is a world that is actively freezing itself to death. It is violating the most basic laws of thermodynamics. Sitting at a lethal minus 380 degrees Celsius, it shouldn't have the energy to do anything. It should be a frozen corpse floating in the void. But instead of holding on to the tiny fraction of warmth it receives from a distant sun, it has constructed a planetary-scale machine in its sky. It is using its own atmosphere as a refrigerator. It is fighting to get colder. For decades, human physics said this was completely impossible. A dead rock cannot manipulate its own temperature. But this world isn't dead. It is moving, it is bleeding, and it is aggressively chilling its own surface to protect a massive, churning secret buried deep underground. A secret that is about to rewrite everything we thought we knew about where life can survive.
For decades, we thought we understood the rules of the solar system. The closer you are to a fire, the warmer you feel. And the further you walk away into the dark, the colder it gets. It's basic, predictable math. When Clyde Tombaugh first spotted a tiny moving dot in the deep black base of space in 1930, we assumed we knew exactly what we were looking at. We called it Pluto. And for 76 years, it was our beloved ninth planet. Then, in 2006, astronomers changed the rules, stripping Pluto of its planetary title and downgrading it to a dwarf planet.
The public was outraged, and we argued over definitions and labels, but while we were busy arguing, Pluto was quietly holding on to a mystery that made our petty arguments look ridiculous. When scientists calculated how cold Pluto should be based on its immense distance from the sun, they came up with a very low number. But when they actually measured it, the math broke. Pluto's surface was hovering around minus 380 degrees Celsius, significantly colder than the predictions. In the vacuum of space, a planet cannot simply lose heat for no reason. If a world is colder than the sunlight hitting it allows, something physical and active must be stripping the heat away. What could possibly be draining the heat from a world that is already frozen solid? To solve a mystery billions of miles away, you have to go there. In 2015, after a grueling 9-year journey, the New Horizons spacecraft finally approached the ice world. Scientists back on Earth braced themselves for a boring revelation, expecting to see a cratered, dead rock untouched for billions of years. Instead, as the first images trickled onto their screens, the control room fell dead silent. They were looking at a masterpiece, a massive, perfectly formed, bright white heart carved into the side of the planet. It was a sprawling plain of frozen nitrogen that was smooth and young, meaning the surface was moving, churning, and alive. But the biggest shock came when New Horizons turned its camera around and looked back at Pluto, perfectly eclipsing the distant sun. Suddenly, a glowing, multi-layered ring of blue light appeared around the planet. Pluto had a sky with haze layers stretching hundreds of miles into space. How could a world this small, cold, and distant hold on to an atmosphere? And what was that haze made of? The answer to that question would unlock the mystery of the missing heat. But humanity would have to wait another decade for the James Webb Space Telescope.
Unlike New Horizons, Webb reads the fingerprints of the universe, analyzing light spectra to break down the chemical makeup of anything it stares at. When Webb pointed its golden mirrors at Pluto, it finally saw what the haze was doing. Normally, an atmosphere acts like a blanket, trapping gases and heat from the sun to keep a world warm. But Pluto's atmosphere operates in reverse. The blue haze floating above the ice is rich in complex hydrocarbons.
When the faint sunlight hits these particles, they absorb the energy But instead of trapping that heat, they radiate it instantly back out into the freezing void of deep space. Pluto's sky isn't a blanket. It is a giant planetary-scale radiator actively refrigerating the planet. It is a world manipulating its own thermodynamics. But this self-chilling mechanism came with a terrifying consequence. The atmosphere is leaking. Pluto's weak gravity cannot hold on to its strange, cooling sky forever, and the planet is bleeding its own gases into the vacuum of space. However, they aren't just vanishing. Floating right next to Pluto is its massive moon, Charon. Over decades, the escaping gas from Pluto drifts across the void and slams into the freezing poles of the moon, where Charon's immense cold traps it instantly. Radiation from deep space then cooks those trapped gases, chemically transforming its own poles' reddish compounds called tholins. Charon is slowly staining its own poles red with the stolen blood of Pluto's sky. Yet, as the Webb telescope peered closer at Charon, it found frozen carbon dioxide and hydrogen peroxide hiding in the ice. These are the markers of complex, active chemistry, proving that both of these worlds are hiding immense dynamic power. Where was this power coming from? If you were to walk across Pluto's freezing surface, you wouldn't just find flat plains of ice. You would find massive mountains of solid water ice and fields of towering, jagged blades made of methane. Most shockingly, you would find signs of cryovolcanoes, volcanoes that erupt with a sludge of freezing water, ammonia, and nitrogen. Volcanoes require energy, movement, and internal heat.
The only logical explanation for a world that is freezing itself from the outside down to negative 380 degrees Celsius, having enough heat left inside to power a volcano, is that deep under the crust of Pluto, there is likely an ocean. A massive, buried, sloshing ocean of liquid water, kept from freezing solid by the faint residual heat of the planet's rocky core and the antifreeze properties of ammonia. We have spent decades looking for liquid water on Mars and the icy moons of Jupiter and Saturn. But here, at the darkest, coldest edge of our solar system, there might be an abyss of liquid water.
This changes everything. If there is water, internal heat, and complex chemistry raining down from the sky, you have to ask if something could be swimming in the dark. We have always assumed that life requires a warm, sunlit world. But what if the ingredients for life can be cooked in a slow cosmic freezer? What if a world that refrigerates its own sky, bleeds its atmosphere to a vampire moon, and erupts ice from deep beneath its crust is exactly the kind of chaotic, churning environment where the spark of biology can ignite?
Pluto isn't a dead rock. It is a survivor, a complex, breathing system of ice, gas, and hidden energy, playing out a drama billions of miles away from human eyes. We went to Pluto to find a frozen graveyard, and instead found a world that might just be holding the blueprint for survival at the edge of the abyss. The next time you look up at the night sky, don't just look at the bright, familiar stars. Look at the empty spaces between them, where a tiny, forgotten world is quietly breathing, hiding an ocean beneath a beating heart of ice. If you like our content, please hit the like button and subscribe for more such space explorations. Until then, stay curious and see you in the next one.